Welcome to Intro to Trigonometric Functions with Mr. Fullington. Today we will cover standard GT10, using trigonometric ratios and the Pythagorean theorem to solve real-world and mathematical problems involving right triangles. A few learning objectives today. First we will identify trigonometric functions and when to use distinct functions. From there, we will take these trigonometric functions and the students will be able to and should be able to solve real-world mathematical problems. Based on the standard, we will also be able to experiment with the Pythagorean theorem to find sides of triangles. Another learning objective for today, students will need to learn to use sine, cosine, and tangent to find trigonometric values for the angles of the triangle. And finally, based on the standard from above, students will be required to use effectively a scientific calculator to find those values and the angles within the triangle. The first topic we'll be discussing today is known as Pythagorean theorem. Pythagorean theorem is a formula used to solve for sides of a right triangle. As you can see, as I've labeled on the screen above, we have three sides, A, B, and C. Side C will always be the largest side. From there, you'll plug the numbers in that are given on the triangle and into the formula and solve for sides. So let's go ahead and get an example up here really quickly. Let's get this off the page. Hopefully everybody's got that down. Get that off, and we'll get a little example. So let's start it off with a right triangle. Remember that you can only use Pythagorean theorem on right triangles. And we'll start off, this side will be 8, this side will be 15, and we are solving for C, of course, because it is the largest side, or the hypotenuse. So let's plug in these numbers. 8 is A, so you'll go 8 squared plus 15 squared, because that is B, equals C squared. Now we know that 8 times 8 is 64, and we know that 15 times 15 is 225. We add those together, 225 plus 64, and we get 289, and we will use our scientific calculators are going to be crucial in this lesson, as you'll find out, so have those out and ready. And the square root of 289 is 17. That is your answer for side C. So we'll write that C equals 17. Okay, we've covered the first section of this lesson. Let's move forward to trigonomic functions and trigonometric formulas. Okay, next topic we'll be discussing are functions known as sine, cosine, and tangent. Now once again, we got an angle here, and this angle part right here is the angle we'll be focusing on for this first example. In these trigonometric functions, you're going to need to identify these three areas. So from this angle, you'll identify the opposite side, or the angle that is opposite of, or the side that's opposite of that angle. So this is the opposite side. Adjacent is the short side that runs with the angle. Adjacent, so we'll label that here. And the large side that runs with the angle, or the largest side, is the hypotenuse. Okay. So there's three trigonometric functions that we're gonna introduce today. I'll write those really quick. And those are as follows. We'll have sine, cosine, and tangent. Get those up here really quickly. Okay. And those can be written as follows. So we'll label this angle A, and from there, this is the notation you'll write. So sine A equals opposite over hypotenuse. Okay, cosine of A equals adjacent over hypotenuse. And lastly, tangent of A equals opposite over adjacent. Okay, now let's work some examples. Give everybody a minute to catch up and look at that a little bit. So we'll get started off with a little example. I'll get it up here on the screen for you guys. Once again, all of this will have to do with right triangles, and I'm not the best right triangle artist, but I will do my best. Okay, so we have a side we are looking for, an angle that is defined as 35 degrees, and the hypotenuse is 10. Okay, so we are going to set that up, and you're solving for x. I'll write that up here. Solve for x. So we'll set it up. We know that this is the opposite side of the angle, and this is the hypotenuse of the angle. So we can determine from the equation we wrote down a minute ago that we'll be using the sine function in this example. So you'll write sine of 35 because that is the angle. You will put equals to x over 10. Now from there we solve it using our algebraic form. So we've got this 10 on the bottom. We need to multiply it over to the other side. We need to flip it over and multiply this by 10 over 1 and this by 10 over 1, which cancels out these 10, which leaves x equals sine of 35 times 10. Once again, you'll use your scientific calculator, and that answer comes out to be x equals 5.736.
Which is here. Now, in order to use the trig functions of sine, cosine, and tangent, they're here in the first column, and I'm going to type in my value of 25 and then click on sine, and notice it types out sine of 25 degrees up here. You want to make sure this is marked on degrees. That's the default for this particular calculator. Your calculator may be different. So sine of 25 degrees equals, and there's the value. And again, what I like about this calculator is it types everything out for you, so you can check what you enter into the calculator. Let's try cosine. 25 degrees, the cosine of 25, and again cosine, notice it has degrees, and 25 degrees equals, and there's the cosine of 25 degrees. Clear it. 25 degrees, the tangent of 25, again it types out tangent of 25 degrees equals, and it gives you the.
Okay, let's work a real world problem, because that was our big objective of today, is to be able to work on some problems that apply to the real world. How would we use this in the world? That's always the big question when doing math. So let's draw a ramp for a car to go off of, or a motorcycle. Let's picture Evel Knievel. I'm not the best motorcycle driver or drawer, so I will draw a car. Not always the best drawer when it comes to cars either. Oh, but I will give it my best. Here, there we go. Okay, this car is going to go over this ramp, but we need to make sure that it's safe. So we're going to set it up as follows. We know that the ramp needs to be 30 degrees. That's given to us in the problem. And we know that we're going to make this a 56-foot long ramp that this car will go off. But we need to know how tall it needs to be to make the landing on the other side. Okay, so we will go ahead and, as we did in the last function, it was a sine function as well, and it just so happens this is a sine function as well. So we will take this, we'll go sine of 30 degrees equals x over 56, looking very familiar to what we did earlier. So you'll multiply the 56 over to here, 56 here will cancel, so x will equal sine of 30 times 56, and we know that that equals, by typing it in our scientific calculator, x equals 28. Okay, guys, thank you for watching this video.